Welcome. In this video I'm going to explain how you can perform or determine the median using Python. Specifically I'm using Jupyter Lab and Python 3, which you can see in the upper right corner here. The median is a measure of central tendency, so it tries to indicate somewhat of a center. And once you know the median, then you also know that at 50% or more is higher or equal to the median, and at least 50% or more is also lower or equal to the median. Now let's have a few examples, and to actually create an example I need to load a file in, and I'm going to use pandas for that. So first import pandas. If you've never used pandas before, you might have to use pip install pandas. And Google a little bit on how to install pandas. It shouldn't be too complicated. And then I'm going to read a data file. It's a big one, so it might have a few errors in there. And what I'm going to select first is something about the World Wide Web, HR hours, so probably how many hours people spend on something. That's going to be the field I'm selecting because that's a numeric field, and I'm going to drop any missing values there. And I can immediately calculate the median from this because pandas has a built-in median function, so I can simply run that, and apparently 5 hours probably is then the median. So at least 50% of the respondents who gave an answer to this question spent 5 hours or more. I don't know if that's per week or per month. That's something you should look up once you're dealing with your own data. You can also use the Python statistics library that comes with Python. So from statistics import a median, and then I can also use the same thing. And it gets, of course, the same result. I can also use NumPy. It's a famous package as well. This one you would have to first install, and then you can use import NumPy as np, and then I can say np median, and that gives me also a nice answer. The same answer as well. However, if we have categorical data, we run into problems. So if I use accounting, if that's scientific, that actually had only values as not too scientific, very scientific, etc. And then if I use median my field, then I get an error because it's not supported for strings. And if I use, I think this was the pandas version, and then I get the same error in the end, basically loads of things, but could not convert string to float. And if I use my NumPy version, I also get an error. So I run into all these errors, and that's because they're not integers, they were text. So now, since this is actually also called ordinal data, we should be able to get a median, but we need it to be numeric. So we need to translate our text to numbers. So first I'm going to have a look at which values I actually had. I'm going to use unique for that. In this case, these were the different options. So I'm going to convert these options into a number, and I'm going to start with not scientific at all. That's going to be 1, not too scientific, that's going to be 2, pretty scientific 3, and very scientific 4. So make sure that this does have the logical ordering. So if I use this, now I can actually replace all my fields that I selected with my coding using the replace option. I'm going to call that my field 2. And if we now have a quick look at the counts, then I can indeed see that there's only numbers and no text anymore. We can easily obtain the median from these numbers now, because my field 2 now only contains numbers, so I can use any of those, and that gives me 2. So the second category is the median, but it would be nice if it actually gives me back what that 2 represented. Was that, well, I know now that looking at this, that was not too scientific, that was category 2. But it would be nice if it just, instead of 2, returns the original value. So I can actually get my keys and my values using converting the keys to a list and the codings as well. And then using this line, I can actually get, based on the index, which was the second one that I needed, I can get back the corresponding label. So that was not too scientific. Another issue with the median is if it falls exactly between two values. So I don't have a clear example immediately of that, so I'm gonna create a new one and run everything here. So I discussed all of that already, but as you can see, this ends up with a median of 2.5. So it's exactly between the 2 and the 3. Now, since this was all text, I would like it to report then that it's not 2.5, but that it's actually between 2 and 3. So that could be between agree and disagree, or exactly between fully agree, between agree and fully agree. So to compensate with that, I found this little bit of code, or created it partly myself. This part I had to grab from somewhere. Adjusted a bit, but what it does in the end is it looks for which two values it falls between in, and then I can say, well, print them between that value and that value. So this nicely gives me that it's between 2 and 3. There's another problem. What if only one or two values need to be recoded? So for example, if we have age, in the age field of my data frame, if you look very closely, you'll see standing here 89 or older. So actually all the other ones are numbers, but this one isn't. So actually all of these are also not really numbers. There's these little apostrophes there. And that will run into some errors for some, except for the Python version. That one actually simply ignores the 89 or older. But I do want to perhaps have it in there, so what I'm going to do is I'm going to recode that one and then convert it to numbers, and that gives me now 47. Whether or not this is acceptable, that 89 or older gets replaced by 89, is an entirely different discussion. Now to avoid the issue, we can create a full coding dictionary from an incomplete list. So here I'm only just replacing one. So what can be useful is to simply select all the unique values. And the full coding is then going to be a new my original coding, and then just replace in case that's needed. So that's why that loop is for. And then I can use keys and values, and I can nicely get still to 47. Alright, I can do all of this in one big function. I'll put a link to this Jupyter notebook in the description of this video. And let's see, this should then run in one go and gives me nicely 47 as a number and as a string. With the hours, the same thing. If it falls somewhere exactly between, this seems to work, and also with my accounting scientific one. Sorry for the long video, but as you can see, there were quite some issues to be tackled. I hope this video was helpful. And if you have any suggestions, let me know in the comments below.